And straight after that, we've got Poppy. If you haven't seen Poppy's channel, go and check him out too. He's good for a chat, he's fun, and he makes cool stuff. And straight after that, we've got Poppy. If you haven't seen Poppy's channel, go and check him out too. He's good for a chat, he's fun, and he makes cool stuff.
Hey gang, Poppy here. We're in the computer room, and I'm going to answer the age-old question: what's inside of a linear actuator? Well, this is a pretty typical linear actuator. AC motor, reversible. I know it's reversible because it came out of a hospital bed. It's one of the ones that lifted either the head or the knee. You see this screw here, this nut, there we go. This nylon nut captured in this tube goes in and out, went in and out on that screw. This piece of plastic here was the tube that guided it. This is a late 60s, early 70s vintage. Doctor write you a prescription, and the hospital supply, surgical supply, medical supply, you know, the guys you got your oxygen and your wheelchairs and hospital beds from. Anyway, this is in there. Let's see. Now push it out. You can see the worm wheel. See if I can position this just right. Zoom you in a little more. Okay. This is the worm wheel coming out of the motor. The shaft here has a screw called a worm that engages this. Turns it either this way or that way, depending on which way or the other the motor's turning. And it turns this. This goes in and out with this guiding it. Okay, this is an AC. Zoom out. This is an AC, alternating current motor. You can tell that by this big capacitor hiding under this tin cover. It's a capacitor start AC motor. One phase, because I don't have three-phase AC in the house. That's an expensive, that's expensive. There's the end bell. Come off of there. So as you see, on one end, you've got this. This is damaged here, obviously. Anyway, this pushes on the head or the foot, or should I say knee mechanism of the bed to raise it or lower it. Because this is turning, because this motor is turning the worm wheel one way or the other. Now when you examine this mechanism, hold still, you. Okay. The worm, turning the worm wheel, which turns the lead screw, which moves this. You have two types. That's two. I don't want anyone with English out there to get the wrong. Because this is not good. This is to the taxi driver who goes roaring past you because you don't look like his kind of passenger. Ah, here it is. You notice these paper towels are going strictly straight into a garbage bag. Okay. Now you have this worm wheel, mechanical advantage, and then you have the screw mechanical advantage. You have two mechanical advantages here. That's why this little motor here was able to push the head of a hospital bed like or the knee of it like you know what I mean? I've shown you the third motor out of that hospital bed. It has shafts going either direction because it lifts the whole bed up or down. That's for the power threading on shear line lathe project coming up. Yeah. I can't see how this is fixed on here. My guess is a one moment while we listen to Mother Nature. Sing, Mama, sing! She's just clearing her throat. Hello, Pancho. Hello. Looky here. Look. Oh, what's that? Oh, you don't like the thunder, do you? Oh, poor kitty. Poor kitty's afraid of the thunder. I know. And look at the doves. They're on the wire over here. Yeah. I can't show you the vacant lot, but they're running around in the vacant lot. They never do that. They're staying close to the ground. They're starting to look for places that they can roost where they won't get wet because it's going to rain. Yeah. You're okay as you got someone to sit on and comfort you, aren't you? Yeah. Hey, looky here. What's this? Oh, yeah. You like that? Yeah. You remember Wiki? Wiki loved that. That was hers. Yeah, that was her hiding place. Uh huh. Okay. Enough of that. go. Showed you this is so you understand this. This right here is this out of my direct current easy chair lift mechanism. The motor was direct current. So I got a direct current machine tool motor controller, reversible, with adjustable voltage and amperage. Yeah. And it runs the DC motor, which actuates the worm wheel, turning the screw. And tonight I got to go out and make this the right size to slip into the Kirby flex shaft attachment portion that it's going to be grafted to. This was fun. I had to cut it like so. The first cut was with a cut-off wheel and a 3/8 reversing drill. Variable speed, right? Just cranked it on and locked it in. One moment here, I blobbed a bunch of this grease on the pet taxi, and before it hits the floor, oh, now this black nasty grease they put in this worm drive. I'd say it's got molybdenum disulfide in it by its color, and it makes sense. You want an enclosed mechanism like this to keep on working and no wear on the mechanism. I'd throw a lot of moly disulfide in that grease. Yeah. Anyway, as I was saying, the first cut was with a Skill 3/8 reversible drill. I had a cutoff disc in it. Made one cut and it died. The trigger shot out. I put it back in. Something was missing. It no want to chooch no more. Like AVE would say, it no choocha. Would probably say it's not going to chooch no more. So anyway, I took it apart, tried to salvage the chuck. Even with heat, that thing don't want to come off. So I'm thinking that gear drive out of the electric drill be another project someday. Screw the chuck. I may probably make a video of destroying the chuck to get it off the shaft. What's inside a Jacobs type chuck? Well, I'm going to destroy this one. If you look real hard, you'll see. Anyway, well, I think I'm probably... Oh, this was the second cut. I made it with angle grinder. Angle grinding wheel. I just came straight in and go... Right? Then I went to my belt sander and flattened the end, and then I did this Higby style thread relief, and it went like basically an entire rotation around the thread to go from maximum thread to nothing. Nice, huh? Did that on the belt sander freehand. This, I clamped it in the vise, and I took the angle grinder and went until the bottom of the thread, the root of the thread was just about to disappear. I figured that'd get me real close to this diameter, which I wanted to be where I started from to turn it down. I'm going to try hard turning this, but I have a feeling I'm going to mount it like so in my rotary table and bring a grinding wheel here and go while this spins slowly. Then again, maybe I'll scallop it every 5 degrees and then spin it against the wheel. Anyway, I got to go out tonight and machine and record. I'm going to I'm going to do something to this to make it the right size to slip into the Kirby flexible shaft drive mechanism. Nah, that's what I'm going to do. And it's 14 minutes. Wow, I managed to waste 14 minutes of your valuable time. I'll put the JPEGs of getting this to here on the video I'm going to shoot tonight. Not on this one. Anyway, good night from California. I hope this has been instructional. You can't see the worm coming out of the motor here, but basically it's a screw. Some of them go straight, some of them are dished so that they fit into, the wheel. Anyway, good night from California. Hey gang, Puppy here. We're in the computer room, and this is a continuation of what I found inside this hospital bed lift mechanism. As you can see, here is the casing. Right? Now, here's the mechanics. The motor, this is the end of the shaft of the motor, has this worm, which turns this worm wheel, which turns this screw. And this, as you can see, has a nut that rides on there. This back and forth in here. Okay, now, what's this carbuncle about? It's about this big capacitor. It's a capacitor start motor. AC, of course. Here's the field coil. It went right there. Ah, that heavy piece of crap. Set this aside too. Under this were these two switches, which were actuated by this cam. There we go. Which you see is attached to a gear, which was driven by these other gears, which got their power from, there we are, right here, this pinion. Turned those gears, and there we are. The pinion turned these gears, which turned this cam, actuating these two limit switches. This is a sophisticated worm drive. This gear, through a gear train, was running a cam to hit the two limit switches. That is something else. That's sophisticated. Now, nylon gear, it was pinned to the shaft. There's the pin. There we go. Nuts and screws, one wire nut. This bronze bushing, there we go, was on the back end here. Of course, you see a real nice ball bearing here. I'm going to scavenge that. And then we had a wavy washer, a nice, really nice flat washer that went along with this. Yeah, thrust bearing. And here's the other side of the thrust bearing washers. Very nice. And various anyway, as you see, various shims, nylon, steel, very, very well thought out mechanism. Of course, like I told you, is a late 60s, early 70s vintage hospital bed linear actuator to lift either the head or the knee. The other one is over there somewhere. It's exactly like it. What else? What else? But anyway, were I to use this here, I'd have to cut this shaft right about here. If I use it in this housing, I'd want to cut it here. Catch a new power source. And of course this, cut this here, and it's your basic worm drive reduction. The screw, that's superfluous. Inclined plane around a cylinder, that screw. In both senses of the word. Only 6 minutes? Wow. Okay. Oh. What else? What else? What else? Okay. See, the motor slid in there, worm first. It was clipped in with that big E clip, C clip. These two screws held the whole case together. They're going out to the shop and be checked for any sign of 1032-ness about them. They look suspiciously like they got 1032ism about them, and if so, we know how to deal with 1032s in Poppy's workshop. Yes, we do. Those gears I showed you were working on these pins here. The switches. Where did I put them switches? Oh yeah, here's the switches. Were like anyway, they were on these pins. And these are some nice pins. Precision ground and polished. They wanted this mechanism to last a long time. And putting those gears and that and switches in here, to control the travel of this whole mechanism is really nice. Well thought out engineering. This was pinned. It was so dirty and nasty. There we go. You see the pinhole, and there's there. Hey, down the Holland Tunnel. Okay, so the last thing. No. Okay. Let's move this stuff. The last thing. Here we are. Okay. The field coils are really massive, and obviously there are two sets of field coils because it goes two directions. This is an induction motor. They usually only go the direction the electricity wants to go, sort of phase-like. So you've got two sets of windings, so it can go different phases, follow different sets of phases and go different directions. Anyway, a nicely constructed one too. Your stack of steel has these 4 holes that go all the way through. It's got a serial number and some stamping over here. I can't quite read it, but wait a minute. Two, four, something, one. Anyway, they serial numbered it. They serial numbered this thing. There we go. They serial numbered. They really cared. They really cared about this mechanism when they made it in the late 60s. By the 70s, they wouldn't have given up. So now, I've got this connector to the junction box for 3 motors. And the bare wires, I could hook any motor up to it. I got this, chop it here, and it's the output part of a very stout worm drive. I told you, these long screws, they're going out to the shop. I think they're 1032s. I'll put them to use after I clean them. And the thrust bearing over here is very nice. That's those 2 switches. The other unit like this is getting took apart too, because I want the switches and the screws and the ball bearings. Yeah, that's that for that. And we're at 13 minutes, so I'm going to graph this on to what I found inside the hospital bed lift mechanism. Good night from California.